Welcome to the Math Record. Today we'll be covering alternating series. This video will cover part 3 of chapter 4 in our calculus class. Okay, let's begin. So what is an alternating series? An alternating series is the sum of sequence of numbers that alternate between a positive and a negative number. So an alternating series would be like if we have a sequence which is like -1, 1, -2, 2, -3, 3. It alternates between a negative and a positive. It doesn't have to be in this order. It just has to be negative and positive. So now the question that we're going to ask is, how do we determine if an alternating series converges or it diverges? So the general equation for an alternating series is the summation, which is the sum, from x is equal to 1 to infinity. And to make it alternating, we just have to put a -1 and then x plus 1, right? So we have an exponent. So then if -1 is raised to 1, then it's going to be negative. -2, -1 raised to the power of 2, that's a positive, right? So this equation just changes it from negative and positive. So we make sure it's alternating. And then we're going to multiply by a of x, a subscript x. So this is going to be our general formula that we want. So the idea is that if our alternating series is in this general formula, then it converges if it satisfies two conditions. The first condition is that as the limit as x approaches infinity, then a of x, a subscript x, has to equal 0. So it tells us that as a of x approaches as x approaches a really big number, that means this equation has to become really, really small. Okay, so the second condition is that a of x has to be non-increasing. Increasing. Okay. So basically all this means is that this as a function, the terms cannot be bigger than the one before it. So what this means is that something like 1, 2, 3, 4 is not is increasing, so it fails the second statement because 2 is greater than 1, 3 is greater than 2, and 4 is greater than 3, right? And 4 is greater than 2, 4 is greater than 1, etc. So this would not be non-increasing because it is increasing. It's increasing as the x increases. So something non-increasing would be like if we have 1, 0, -1, -2. So it's non-increasing because it goes from 1 to 0, so it gets smaller. 0 to -1, smaller. -1 to -2, which is smaller, right? And -2 is smaller than -1, is smaller than 0, is smaller than 1, right? Or if we have something like 1, 0, 0, -1, -1, -2, right? 0 and 0, it stays the same, so it's still non-increasing. It just has to be not increasing, basically. So it could be either decreasing or the numbers stay the same as the sequence goes on in that order. So it just has to satisfy these two conditions. So let's try an example to understand this. So let's say we have a summation of x is equal to 1 to infinity. And we have -1 to the power of x plus 1, right? As a general idea. And let's say our formula is 1 over x factorial. So it's alternating, right? So is this alternating series increasing or decreasing? I mean, is this series converging or diverging? Sorry about that. So let's check our two conditions. Is the limit as x approaches infinity of a of x, which is 1 over x factorial, is that equal to 0? Well, as x approaches infinity, it gets really, really big, right? So x factorial gets really big, but it's 1 over that really big number. So it gets smaller and smaller and smaller. So since it's getting smaller and smaller, that means the graph will look something like this. It looks like a reciprocal, but it's not. So so it gets really, really small and it's got approach 0. So it's a really, really small number. So this is true. Number 2. So is 1 over x factorial non-increasing? Well, we just need to check some of the terms. So on these conditions, you usually just plug in like a few numbers. I usually just plug in the first four numbers. So when x is equal to 1, 1 over 1 factorial is 1. When x is equal to 2, that's 1 over 2 factorial, which is just 1 half. When x is equal to 3, we have 1 over 3 factorial, which is 1 over 6. And when x is equal to 4, we have 1 over 4 factorial, which is 1 over 24, right? 1 to 1 half is decreasing. 1 half to 1/6 is decreasing. And 1/6 to 1/24 is decreasing. So since it's generally decreasing, that means we know that 1 over x factorial is not increasing, right? This is not increasing in this series. So this, oh, sorry. So this series, infinity, the summation from x is equal to 1 to infinity of negative 1 to the power of x plus 1 times your function, which is 1 over x, x factorial. This as a alternating series would be non-increasing. And the limit will approach 0, but it's also going to be converging. So the follow-up question is that how do we approximate the sum of a converging alternating series? We won't be able to find a exact sum, but we would be able to get very close to it. So the idea is that let's kind of use our previous example where we have a summation from x is equal to 1 to infinity, right? And we have negative 1 to the power of x plus 1 times our equation, which is 1 over x factorial. So the idea is that if we approximate the sum of a converging alternating series, we kind of like want to find it to a certain decimal point. So let's say we want to find like the sum of this series within an error of like 0.00001, right? So tens, hundreds, thousands, 10,000, hundred thousands within a hundred thousands margin, right? So it gets like kind of really close, like a really close approximation to the actual answer. So what we had to do is that we had to check for the first x value, which is less than 0.00001, right? So it has to be less than this number. So the first one we had, so all you have to do is that you just need to check this, right? So it's 1 over x factorial. Oops, sorry. 1 over x factorial is less than 0.00001. And if you use the calculator, the first time that ever happens is when x is equal to 9. It's not going to be a decimal. You're going to have to use like whole numbers, right? So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., right? So the first time it happens is when x is equal to 9, if you use your calculator. Okay, so let's kind of store that up first. So we know that the first time that x is less than 0.00001 is when x is equal to 9. So what we do now is that we take the sum of x is equal to 1, the beginning number, and then whatever we have on this answer, we subtract 1 from it. So we have 9 subtract 1, that's 8. Okay, so we put an 8 on top because we're not going to infinity now, we're going to 8. And then we put negative 1, x plus 1, so we just put the general formula again, times 1 over x factorial. And you plug this into your calculator, you get something around 0.63212. And that's generally your answer. And that's all you had to do, basically. Because the general idea of how to find this is kind of like intuition. If your x is equal to 9, right? The first time that this is less than this number, that means anything after that kind of doesn't matter because it's so small that it's not going to affect this. So anything before it will then be able to affect it to some degree, right? So then x is equal to 1. To 1 less than it, it's 8. is from all the terms from x is equal to 1 to x is equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. All those matter because those are going to be the ones that are within this bound, right? So it's going to be like for example, this is not a precise answer. Says point like 2 like point 1, 2, 3, 4, right? So this is going to matter if one of the terms come out to that, which doesn't. I'm just using it as an example. So since 0.1234 is like greater than 0.00001, right? Then technically that thing matters when we're approximating that number matters when we are approximating the final answer. But if we have something like if we want to plug in from x is equal 1 summation up to 9, then we have to put a negative 1, right? 9 plus 1 times 1 over 9 factorial, which is smaller than this, so it makes no like change to this answer if you're approximating within this interval. But if but the general idea is that you just need to follow this procedure. Whatever the first time the x value is less than your error bound, you set that equals to that number, and then you take one less than that, and then you plug it back into your equation, and you get your answer. And that's the general idea of how to approximate for alternating series, alternating converging series. Well, that basically covers everything for alternating series. Thanks for watching, and I'll see you at the next math record.